In this video, we're going to use our financial calculator to solve for the present value and future value of an annuity. An annuity is going to be a finite series of equal payments that occur at regular intervals. Finite means that it's going to be less than infinity, equal means that they're all going to be equal, and regular intervals mean that it's going to occur at some regular interval like every quarter, every month, or every year. If the first payment occurs at the end of the period, we call that an ordinary annuity. And if the first payment occurs at the beginning of the period, we call it an annuity due. Here we see our variables, where our time is going to be the number of years multiplied by the number of time periods or compounding periods in a year. Our interest rate is going to be the annual rate divided by the number of time periods in a year. We're going to call that a periodic rate. Our present value is going to be a cash flow at time zero. Our payment is going to be our annuity, and that's going to be a finite series of equal cash flows that occur at regular intervals. If the cash flows are not all equal and they vary over time, then we cannot use that value for our payment in our financial calculator. And then our future value is going to be some cash flow in the future or the value that we're going to solve for in the future. And so here we see our first example. Assume you would like to retire in 40 years. You're able to save $4,000 at the end of each of the next 40 years. So first we have to figure out if we have an annuity. 40 years, that's less than infinity. The payments are all $4,000, so they're all equal, and all of the payments occur at the end of each of the years, so that's a regular interval. If we are able to invest in the stock market and earn 7% per year with annual compounding, we want to know how much we're going to have at retirement. And so our inputs are going to be that our payment is equal to $4,000, that's our annuity. Our T is going to be equal to 40 times 1, and our R is going to be that periodic rate, or in this case 7% per year. And so here we see the formula version and also our inputs, and then our layout for our time value of money functions on our calculator. So here we see our BA2 plus, and anytime we're working with our BA2 plus and the time value of money functions, the first thing we want to do is make sure that we clear our time value of money tables. So we're going to hit second and then clear TVM, or the future value key. And then our N is going to be 40, so we're going to type in 40 and then hit N. Our interest rate is 7% per year. And on the calculator, we do not type it in as a decimal. We just simply use the number. So I'm only going to hit 7 and then IY. Our PV is 0. In this case, we don't have any present value or an amount that we're starting with at time 0. So we're going to hit 0 in PV. Our payment is going to be our annuity. And in this case, we're going to assume that we're saving it or investing it. So we have to make it a negative number. So first I'll type in 4,000 and then hit our plus minus key. And then PMT. And we want to calculate our future value, so we have to hit CPT and then FV. And so here we see that if we were to save $4,000 per year and earn 7% on an annual basis, by the time we retired, we'd have $798,540.45. So now we can look at a second example. And in this case, we're still going to retire in 40 years. But we're going to assume that we save $300 at the end of each of the months for the next 40 years. We're also going to earn 7%, but we're going to have monthly compounding. And again, we want to know how much we're going to have at retirement. So here we see our inputs where our PMT is going to be $300. Our R is going to be a periodic rate. So we take our 7% or 0.07, again if we were using the formula, and divide it by 12. Our T is going to be 480. So again, you see the formula inputs and the calculations there. And we also have our table for our inputs for our time value of money functions on our financial calculator. Anytime we work with a time value of money worksheet on our financial calculator, the first thing that we do is we want to clear those values. So I'm going to hit second and FV. And then I'll clear the value that's stored in the calculator here. And now we're ready for our inputs. And the first thing we're going to type in is our N, or our number of time periods. And in this case, it's going to be 40 years times 12 months in a year, and we're going to have 480 time periods. So I'm going to type in 40 times 12. And it's important here that you hit equals. If you did not hit equals, it will store the number 12, and we don't want that. We want it to store the number 480. Then hit our letter N. Our next input is our interest rate or our yield, so we're going to type in 7 divided by 12 equals. Again, we hit equals to make sure that it stores the correct value. And then IY. And in this case, there's no reason to round here. We're just going to use that number that it's stored. Our PV is 0. So I'll hit 0 in PV. Our payment, that's our annuity. That's how much we're going to save every month. And because we're assuming it comes out of our wallet, we remove it from our wallet, we invest it, that it's going to be a negative $300 per month. So I'm going to type in 300 and then hit the plus minus key and then our PMT. And then we want to calculate our future value or how much we're going to have at retirement. So I'll hit CPT and FV. And in this case, we'll have $787,444 at retirement. If we assume that we save $300 every month for 40 years, earning 7% per year with monthly compounding. Now we're going to look at our present value of an annuity. And in this example, we're going to assume we're going to receive $2,000 at the end of each of the next 5 years. So the first thing we have to figure out is, do we have an annuity? This is an equal $2,000 payment. It occurs for less than infinity, in this case only 5 years. And it happens at the end of each of the next 5 years, so that's a regular interval. Our discount rate is 8.5%. We're going to assume that's annual. We want to know what the value of it is. There we can see our timeline. Our formula is listed as well, and then our inputs using the formula. Again, it's important to note the difference between using R for our formula. So you'll see here that we use it as a decimal, 0.085. But with our financial calculator, we would type that in as 8.5. So here again, we have our formula, and then we have our inputs for our time value of money functions on our calculator. And so anytime I work with the time value of money worksheet, the first thing I want to do is clear those values. Next thing we'll do is type in our N, and in this case it's going to be 5 years, and there's going to be one compounding period per year because we assumed annual compounding. And then N, our interest rate or our IY is going to be 8.5%. In this case, we just type in 8.5 for our financial calculator. So 8.5 and then IY. PV is what we're calculating, so I'll skip over that. In this case, our payment is going to be listed as a positive amount. And the reason I'm going to list it as a positive amount is because that's how much we are going to receive. It's going to be a cash inflow to us. So I'm going to type in 2,000 and then PMT. Our future value is going to be 0. 0 FV. And now we're going to compute our present value. And that cash flow is going to show up as a negative amount. And the reason it's a negative amount is because it assumes that we would have to pay for it or invest a certain amount in order to receive those $2,000 payments. Here we see our second example. Suppose you visit a financial advisor and she offers you an investment that's going to pay $2,000 a month for 25 years. Financial advisors and insurance representatives often have an insurance product or a financial security that they call an annuity, or that annuity is going to promise some stream of cash flows. In this case, $2,000 a month for 25 years. And so what we're going to try to calculate then is how much we think that should cost. We have to make some assumptions, and that's going to be that it's 6% per year. And it does say monthly compounding here, but we could assume that when it's $2,000 per month. And so we can think about it two different ways. How much would be a fair price for it? And then how much it would cost us if we wanted to recreate that annuity. Here you see our formula inputs. And again, the formula and the inputs for the formula. And then in the table, we have the values for our time value of money functions. So our N in this case is going to be 25 years times 12 months in a year. And so I'll hit 25 times 12 equals. And again, we need to make sure we hit equals. If not, it will store that 12. And then N. Our interest rate is going to be 6 divided by 12 equals. And then I'll hit IY. Our PMT is going to be $2,000. It's going to be a positive amount because that's how much we're receiving every month. It's going to go into our wallets. So I type in 2,000 and then hit PMT. Our FV in this case is going to be 0. And we're trying to calculate the present value or the price of this annuity. So I'm going to hit CPT and then PV. And here you see that annuity will cost us $310,413 and about 73 cents. In this case, we'd be willing to pay $310,413.73 for that annuity. And another way to think about it would be that we could recreate that annuity if we earned 6% per year on the money that we had saved, if we took out $2,000 a month for the next 25 years.